Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In a previous video of the polymer science, we have understood different polymerization processes, in which we have seen how we can convert our raw polymer into the day-to-day useful types of the final product of polymer. If you have missed that video, you can find it in the I button on the top of the screen. Now, having said that, let's just move to the next chapter of the polymer science and technology. And that is chapter number 2, which is basic concepts of the polymer. In this chapter, we are going to deal with some basic concepts that are being used in order to understand this polymer science. And the first basic concept of the polymer is the molecular weight. And the first basic concept of the polymer science is the molecular weight. As you may recall that a molecular weight can vary from a single digit unit to the millions of units, right? As the substance such as hydrogen has molecular weight of only 1, while very complex polymer such as polyethylene has very large number of molecular weight. So as you can see here on the screen that the molecular weight can vary from a single digit for a simple chemical substance such as hydrogen to a number in a millions for a complex polymer. So a complex polymer can have million number of the molecular weight. A simple compound such as fixed molecular weight such as acetone, for instance, right? For if you take example of acetone, then acetone has the molecular weight of 58 grams per mole. Regardless how we are going to manufacture acetone, if the final product is your acetone, then it will have always molecular weight of 58 grams per mole, right? But if this 58 gram per mole becomes 60 gram per mole, then the product will no longer be the acetone. It will be converted into the acetic acid. So the molecular weight is very important and it plays a very significant role to identify particular atom or particular molecules, right? As we have seen, acetone has molecular weight of 58 grams per mole. Regardless how we are going to manufacture the acetone, ultimately it will have molecular weight of the 58. Now, as you can see here in this particular image, this is the example of the polyethylene. If we take example of this polyethylene molecule has wide range of its structure, right? So its molecular weight will also vary based on its structure length. Longer molecule will have larger molecular weight and even shorter molecule will have shorter molecular weight. But ultimately its product will same as polyethylene, right? Even its ethene monomer has a specified or fixed molecular weight. But its polymer has variety and it has different shape and it has different length, and based on it has different molecular weights as well. So as you can see here in the screen that the ethylene, or we can say the polyethylene molecule, have different structure with a different molecular weights. So based on the length of polyethylene, we will decide its molecular weight. As you can see here, we have taken 500 monomers of ethene molecule combined together to form polyethylene molecule, which will have molecular weight around 14,000. Then if we take monomer of ethylene molecule to 550 monomers, then the polymer formed with this 550 monomer will have molecular weight ranging from 15,000 to 15,400 grams per mole, right? If we increase the number of monomeric unit to 600 monomeric unit, then they are combined together to form polyethylene of 600 monomeric unit. Then it will have molecular weight of the range around 17,000 grams per mole, right? So as you can see here, all of this structure are of the polyethylene, but they have significant change in their molecular weight. The first one has the molecular weight of 14,000, while the third one or the last one has the molecular weight of 17,000, right? Approximately 17,000, which shows that even though your product or your final product is the same polyethylene, but its molecular weight can be changed. So this phenomena will lead us to define our average molecular weight of any particular polymer product. Now, as you can see here, these three molecules have different size and their molecular weight are also different. But yet, all of these three molecules are very much polyethylene only, right? So even though this product is same, but their molecular weight are very much different. And this leads us to the concept of average molecular weight. Now, to understand this average molecular weight, we have developed two more concepts such as number average molecular weight, and one more thing is there which is known as the weight average molecular weight, right? But before understanding these two things, let's just take one example by which we can understand them very easily. So as you can see here in this screen that we have considered one basket which has been containing three different vegetables such as onion, brinjals, cabbage and cauliflower. So there are four different vegetables inside one basket, right? Here this table particularly shows their number and their molecular weights, right? So just for the ease of understanding, let each onion of the onion lot weight same, right? And so do all the other vegetables. So the weight of all the onions is same, and same weight of the all brinjals are being considered as the equal. And similarly for the cabbage and for the cauliflower. So now assume that the number of each vegetable and its weight are being represented by this table. So the number of onion is 2, then brinjals are 4, then cabbage has 6 numbers and cauliflowers has 3 units, right? So we have 2 onions, 4 brinjals, 6 cabbage and 3 cauliflowers, right? So these are the different units. So ultimately we have 15 vegetable in our basket, right? And these are the average weight of individual vegetable. Onion has an average weight of 10 grams. Then brinjal has an average weight of 20 grams. Similarly, 100 and 250 grams of the weight of cabbage and cauliflower respectively. Now, if we find the total weight of individual vegetable, then the weight of onion is around 20 grams, right? As we have 2 onions and each onion is of 10 grams, then ultimately the total weight of onion is 20 grams. Then weight of brinjal is 80 grams. Cabbage has the total weight of 600 grams and cauliflower had weight of 750 grams, right? We have to just multiply these two units. That means we have 3 units of cauliflower and each unit has the weight of 250 grams. So ultimately 750 grams is the total weight of the cauliflower. So we can see here ultimate weight of the basket is having 1450 grams, in which we have 15 units of different vegetables. Now, after understanding this table of the basket, let's just quickly move to the concept of number average molecules, right? So as you can see here, now we have to find out the average weight of the vegetable present in the basket, right? So now we have to focus on the average weight of the basket. So so in order to do this, let's just assume that the individual vegetable entity contribute to the average weight in the proportion of its number. So if the onion numbers are 2, then it will contribute the same amount to the average weight of entire basket, right? So what we get at the number average weight is, now let's just do some mathematical step in order to get this number average concept of this basket. The total number of the vegetable contained in the basket are 15, right? As we have represented in the previous table. Now let's do one exercise for the onion first. As the number of onion present in the basket is equal to 2. We have two numbers of onion in the basket. Then if we find the fraction, or you can say the fraction of the onion present in the basket, then it will be 2 divided by 15. That means individual unit by the total unit. So individual unit are 2 and the total unit are 15. So the fraction of onion will be 2 divided by 15, right? Now similarly, the fraction of brinjal, cauliflower and cabbage will be 4 by 15, where we have 4 units of brinjals, then cabbage is 6 by 15, in which we have 6 cabbage. And lastly, for 3 cauliflower, we have fraction as 3 divided by 15. Now, if we move further in this concept, then the contribution of 2 onion made towards the average weight of entire basket can be determined by the number of fraction of onion, that is 2 by 15 into weight of individual onion. So the weight of individual onion we have seen in the previous table is 10 gram. So here we can do this maths as 2 by 15 into 10 grams, which will ultimately lead us to the answer of 1.33 grams. So the contribution which is being made by the 2 onion towards the entire average weight of our basket is 1.33 gram. So in an average weight of a basket, we will have 1.33 gram of the onions. Now if we do same math similar to this onion to the brinjals, cauliflower and cabbage, we will have for a brinjal 4 divided by 15 into 20 grams, where 20 grams is the individual weight of our brinjals. Hence we have answer of 5.33 grams. Then similarly, contribution made by 6 cabbage to the average weight of the basket, in average weight of the vegetable in the basket is 6 by 15 into 100 gram, where 100 gram is the individual weight of the brinjal, of the cabbage, which will lead us to the 40 grams. Then similarly, contribution made by 3 cauliflowers into the vegetable inside the basket is 3 divided by 15 into 250 grams, which will lead us to the 50 grams. Now if we sum up all this average weight of individual vegetable, then we will have 96.66 grams of the average weight of our basket. So this is the average weight of the vegetable inside the basket, which is 96.66 grams, which is nothing but your summation of all the vegetables that have been made contribution towards the average weight of the molecules. So this can be defined as the number average concept for this specific example of vegetables inside the basket. Now after this number average concept, we are going to understand weight average concept as well, right? And after that we will implement this concept inside our polymers. Then we will understand how this concept can be easily implemented into the structure of polymer, and how do we can get idea of number average polymer and weight average polymer, right? So these all the exercises need to be understood to get the average molecular weight of one polymer. Now we conclude today's lecture, and in this video we have understood the concept of average molecular weight, as the molecular weight of polymer will definitely based on, or it will depend on the chain structure of the polymer. As we have understood, the polyethylene has different molecular weight based on the structure, right? But still it is the same molecule of the polyethylene. Hence we have to develop one concept of the average polymer and average polymer molecular weight, and that will lead us to develop more concept of the number average molecular weight and weight average molecular weight. So in order to understand that, we have taken one example of the vegetable inside the basket, and we have do all the maths to understand this number average molecular weight, which is being represented by this particular line, right? So now in the next video we will do same exercise for the weight average molecular weight as well. Till then, keep watching, keep learning. Thank you.